All right, we're going to look at the final thing for chapter 9 and do dot products. So it's just another operation we can do. Let's say we have two vectors. The dot product, so multiplying them together essentially, gives us this. V times W is A1 times A2 plus B1 times B2. So let's just look at these. We could say that P times Q is 5 times 1 plus negative 2 times negative 9. So 5 plus 18, which is 23. So got another one. So R times S would be 0 times negative 2 plus 4 times negative 4. So 0 plus negative 16, which is just negative 16. Right? It's okay that these have I and J in them. We can just take the coefficients of them. So VW is 7 times negative 1 plus 8 times negative 9. So negative 7 plus negative 72, which is going to give negative 79. Same thing here. CD will be 3 times negative 2 plus negative 7 times negative 2. So negative 6 plus, let's see, negative times negative is positive. And then we get 8. All right, have a new word in here, orthogonal. Just means perpendicular. So the product, if it's equal to 0, means that the two vectors were perpendicular. So let's just see, are they? So m times n is 3 times negative 28 plus 7 times 12. Well, 7 times 12 is 84, and 28 times 3, let's see, is also 84. So negative 84 plus 84 is 0. So yes, these are orthogonal. Let's see if these are. G times H is negative 3 times 40 plus negative 2 times negative 15. So it's negative 120 plus 30, which is negative 90, which is not 0. So no, these are not perpendicular. Alright, x, y would be negative 5 times negative 1 plus negative 1 times negative 5, which gives 5 plus 5, which gives 10, which is not 0. U times v is 12 times 9 plus negative 18 times 6. 12 times 9 is 108. And 18 times 6 is also 108, which does give me 0. So yes, these are orthogonal. All right, here's some different properties of dot products. So V times W is going to be the same thing as W times V. Multiplication is commutative, so the order does not matter. We have V times W plus X. We can use the distribution property, so we can say that V times W and V times X is the same thing. Same thing if we had a like scalar multiple on the outside, I can distribute that to either one. So I could say, hey, K times V times W, or I could say V times KW. It's all the same thing. Because it's being multiplied, you multiply it to 1, not to both. 0 times v is 0. And v times v, same thing as the magnitude squared. All right, let's look at another piece of information here. The magnitude of the dot product. Well, if multiplying them together, so dot product is the magnitude, then, or magnitude squared, then the magnitude is the square root of v times v. So let's look here. So magnitude of r, that's the square root of the component squared so that's going to give me 26. All right. So this would give negative root 7 squared plus negative 13 squared so let's see. Negative root 7 times negative root 7 is just going to be 7. Let's see, 7 plus 169 is 176. And I'll leave it like that. All right, we can do the same thing here. So the negative 2 squared plus the 18 squared to give 4 plus 18 and 18 to give 328. And I'll leave it like that too. Okay. So the angle between two vectors. A lovely little formula we can use here. Cosine of theta is v times w over magnitude of v times magnitude of w. If we get an angle to give 90 degrees, then the vectors are perpendicular. If the angle is 0 degrees or 180 degrees, then the vectors are parallel. So let's look at some. Let's find the angle between each pair. So let's use that formula. I'm going to rewrite it over here just so I can see it. Okay. So cosine of theta is going to be the dot product of v times w. So that is 8 times negative 7 plus negative 7 times negative 3 all over the magnitudes. So for the first one, that is going to be 8 squared plus negative 7 squared. I don't know why I put plus, because that is multiplying. And the other one is negative 7 squared plus negative 3 squared. So cosine theta, let's see, negative 56 plus 21 over, let's see, that's 64 and then 49. So that gets me 113. And then that's 49 and 9 to give 58. Let's see what we can do from here. So negative 56 plus 21 is negative 35. And these radicals, I can multiply the numbers in them. So I can do 113 times 58. And then, so what I have is cosine of theta equals negative 35 over the square root of that large number. And to get the theta by itself, we can do the inverse cosine. So inverse cosine of negative 35 divided by the square root of 6554. Making sure we're in degree mode. Theta is going to be 115, and let's round it to, so 62 degrees. Okay, let's do another one. So cosine of theta, the dot product over the magnitudes. So cosine theta, let's see, that's going to be 0, so 30 on top. And then that just is going to give me square root of 36, which is 6. Let's see if this gives me anything. 9 plus 25 is 34. Okay, so we can do inverse cosine now. So inverse cosine of 30 divided by 6 times the square root of 34. So theta is 30.96 degrees. All right, let's look at these last two here. So cosine theta is the dot product, so 6 times 9 plus 7 times negative 6 over the magnitudes. So cosine theta, let's see, 54 plus a negative 42 is 22. 36 and 49 is 85. And let's see, 81 plus 36 is 117. So clearly I have 22 over square root of, I'm going to multiply 85 and 117. Wow, that's a big number. 9945. And then I'll do the inverse cosine to that number. So inverse cosine of 22 divided by the square root of 9945 gives me theta of, did I do something wrong? 54 minus 42. Oh, that's definitely 12 and not 22. So that's going to change that number. So cosine, or inverse cosine of 12 over the square root of 9945. That's going to give me 83.09 degrees. All right, and this last one here. So cosine theta of 1 times negative 3 plus 2 times negative 6 over, let's see, 1 squared and 2 squared, and negative 3 squared and negative 6 squared. So let's see, negative 3 plus a negative 12 is 15, negative 15. And then let's see, 1 and 4 makes 5, and 9 and 36 makes 45, which gives me 225, and I believe that's a perfect square. Yep. So negative 15 over 15 So cosine theta is -1. So you can think, where is cosine of theta equal to -1? Or you can do the inverse cosine of -1, and you'll get 180 degrees, which means that the vectors were parallel. And there we have it.